Hello guys, welcome back to my YouTube channel. This is Daniel Rosehill here. When it comes to using optical media for archival storage, checksums are a very useful tool because they represent a digital way to ensure that the data you've burned onto optical hasn't been corrupted by bit rot during its time in cold storage. Of course, those of us archiving onto archival kind of hope that we don't face bit rot, and we might use a media that's supposed to be impervious to bit rot, such as the M-disk, in the hope of not having that problem. In that case, running checksums could be a useful way to make sure that the disk has lived up to its marketing claims. One nice project idea would be to create a test M-disk. Simply take a file from the internet, calculate its checksums using whatever algorithms you like, burn that disk, and then pull out the disk at 5-year intervals, run the checksums on the file, and see have they changed. You can easily do this in most checksum programs by comparing the original checksums against the ones you generate from the test disk. For today's video, I simply chose a pretty small file that would fit onto a CD, so to avoid showing off data that I pirated, I went looking for movies that were in the public domain, and I came across this nice little library from the US Library of Congress. Popeye the Sailor meets Sinbad the Sailor is now officially in the public domain, and it also conveniently fits onto a single layer CDR. It's only about 600 megs in size. So I chose this as my test project. Firstly, I downloaded the MP4 onto my local machine, which is running Ubuntu Linux. Next, I burned this onto the CDR. This was a pretty quick burn that only took a few minutes to complete using K3B. Next, I used a GUI tool called QuickHash GUI to generate the checksums. This is a free piece of software available at quickhash-gui.org, although of course you might also prefer to run the checksum calculations on the command line. I generated checksums using various algorithms on the file that I downloaded from the internet. This only took a few seconds, and I recorded the checksums that were generated into a Google Doc. Next, using the GUI, I was able to calculate the checksums of the movie directly from the attached optical media. This involves reading through the entire file directly from the optical drive, so it took quite a bit longer than calculating the checksum from the local file. So if you just want to do this process for testing out generating checksums, my advice would be to use about a 500 megabyte file, because if you're calculating this on something like a 10 or 20 gigabyte tar GZ, it would take an awfully long time. And then, just as they should have, I found out that the checksums matched up. Just to be doubly sure, I used the checksum comparison tool built into the software. I pointed it to the file on my local machine and onto the same movie file on my CDR, and again we can see that there was a perfect match. So that's how you can generate checksums on optical media. If you want to generate a checksum of the entire optical disk itself, then you can do this from the command line. You can figure out what drive identifier has been assigned to your attached optical storage in the drive's utility. Then run SHA-256sum as a super user. In my case, the command was sudo SHA-256sum/dev/sr0. Again, remember that the checksum process is now going through literally everything that's stored on this piece of optical media. So depending on how much you have on your disk, you can expect to wait some time to get the results. There are advantages and disadvantages to taking checksums at the device level as shown here. If individual files become corrupted, you won't be able to know exactly which ones. You'll just be able to see that some data on the disk somewhere must have become corrupted. One idea that I've had is to burn your data as a few archive files and take checksums on those. This would make the verification process a bit easier, but again, you won't be able to know exactly which files possibly went bad. QuickHash has a pretty nifty folder for importing a folder and getting individual checksums on all the files, so you could also just do this and record those checksums for later verification. I haven't figured out how to do this automatically, but there are some very clever people on the internet who have come up with elaborate systems for exporting all the individual checksums after burning, retaining them for later verification, and then periodically checking them against those calculated from the disk at a later stage. Hope this helped at least a little. Thanks for watching, and until next time.